Hey everybody, this is Quasar. I just want to walk you through the energy lab that we have for this week. I love Nova, PBS Nova. They make really awesome documentaries and these really cool labs that are interactive. And so I thought this was the best way to learn about energy because it's a little hard to do a hands-on lab about it without the right materials like, wind turbines and motors and things like that. Although, like, totally more power to you if you want to test out some cool energy labs at home, like making a light bulb light up with a pickle or something like that. Anyway, moving on. So for this lab, there are 3 tabs up here that you're going to work through: using energy, finding alternatives, and storing and moving energy. Each one has a short video and then a set of 3 questions. You watch the video, you write any notes here, and I'd love to see your reflections and connections, especially because we have the energy slam this week, so you might be finding some cool information. Answer the 3 questions for each tab, and when you click next, it'll bring you to the next question. And then there's 3 for each tab, and there's 3 tabs. And once you're done with that part, you click on My Lab Report, and this is the energy lab. And then so you would click on HTML, and also this would have a green check mark by all of those if I had actually done them. And then once you click that HTML button, it pops up with a lab report that will look something like this, although it'll have like incorrect for all of your answers. And I'm just grading this based on completion. So it's okay if you got some wrong. And then you would copy and paste this link into your Schoology submission spot for this lab. There is totally an extension, and it's awesome. And this is a way that you could achieve a 4 on the assignment if you're going for a 4. And that is to design a renewable future for one of these cities. So I picked Boulder, Colorado, just because I was interested in it, and I think it's kind of similar to Olympia, Washington. And the challenge here is that Guest Energy Alternatives has been awarded a contract to increase Boulder's renewable energy production by 5%. So this is a very realistic design challenge that we're offered here. And currently their energy profile is that they get 68% from coal, 22% natural gas, et cetera, et cetera. And they do have a budget of $300 million. So yeah, let's do it. Let's design a system. So once you click on here, they're going to give us 2, well, they might have different options depending on the city, but Colorado has 2 renewable energy options: solar and wind. And now I got to kind of think about Boulder, and is it like windy? Does it get a lot of sun? Does it get a lot of sun throughout the year? What are their energy demands, and how does that line up with the energy systems that I'm using? And so for solar, I have like a certain amount of square foot amount of area that I'm going to be able to put solar panels on, and the available area is 20 square kilometers, or about 5,000 acres of land. And I have a difference of efficiency. So solar panels are more expensive depending on how efficient they are, but the efficiency might pay off in the end. So I'll just kind of noodle around here and say, like, let's take up all the available area that we have for solar. Why not? And then, because we're over budget, that's why not. All right, coming down. Let's say there. 0.4 kilometers squared. And then I will say that we'll have like, I don't know, the same-ish amount efficiency. So not super low end, but not high end either. And then let's balance that out with some wind. And this is the diameter that it's going to take up, the wind turbines themselves, and the number of turbines that I have. Okay, and it looks like I can only get about that many, 8 wind turbines. Wow. Maybe if I lower the diameter, but okay. I did this way better the first time around. So there is sort of like this balance that you can meet for most efficiency and the most kind of like bang for your buck. So let's test our system, and it's going, warning, low power. I did much better the first time I did this. Anyway, so it's going to do a model basically of your power system throughout the year. So some of Boulder's poorest months for wind power are also peak times for energy demand. Before you move into the calm, hot days of midsummer, you might want to reconsider your mix of energy sources. So I probably need more solar than I actually put in this test. So I could redesign, or I could keep going and see what happens. But I think this system definitely needs a redesign. So this is a really cool like national challenge that you would be doing with other students to design the most efficient system for these cities. So definitely encourage you to dive a little deeper with that and see what happens. And to post your results for this one, you could just do a screen cap of your results. Yeah, go forth, conquer, learn about energy.